let A be this matrix. In first column, we have 2, 4, 6. Then in second column, we have these unknowns P. And then in third column, we have Q with some constant also. Now, if determinant of adjoint of 3A, this is 2 raised to m into 3 raised to n, where m and n are natural numbers, then we have to find the value of m plus n. Now, this is not a difficult problem. I mean, one can very easily calculate the determinant of matrix A, and then using properties of adjoint and inverse, you can find this determinant of adjoint of 3A, and from there you can calculate m and n. But in this problem, there is one shortcut method, that because this is given determinant of adjoint of 3A, this is given in terms of 2 raised to m, 3 raised to n. There is no p or q in this equation, right? M and n, these two natural numbers, and determinant of adjoint of 3A, this is 2 raised to something multiplied by 3 raised to something. So if there is no p or q for determinant of adjoint of 3A, so that will mean that determinant of matrix A, this must be independent of P and Q. Right? It is not difficult to show that result. I mean, if you want to get rid of P, then in place of C2, you can write C2 minus, and then 2, 4, 6, and here we have 1, 2, 3. So basically half of this column, and that multiplied by P into C1. So that will get rid of these three elements, these three terms P, 2P and 3P. Similarly, you can get rid of Q also and P from this third column. But here, because the determinant of adjoint of 3A, this is independent of P and Q. The determinant of matrix A, this must be also independent of P and Q. So you can take any value of P and Q, and we should get the same value of determinant of A. So here what we'll do is, in place of P and Q, we can take 0, right? If I take P as 0 and Q as 0, then determinant of matrix A, this will be 2, 4, 6. Then we have 2, 6, 12. And then third column will be 2, 8, and then 20, right? So, I mean, there is no need to show that the determinant of this matrix is independent of PQ. It has to be independent of PQ because otherwise, this thing will not be a constant, right? This will not become 2 raised to m. I mean, it will include P and Q also. And now from here, we can very easily calculate determinant of this one. In place of C1, I mean, if we want, we can create two zeros. So in place of C1, we can write C1 minus C2. And in place of C2, we can write C2 minus C3. So in that way, we can create two zeros in same row, and then we can expand along that particular row, right? So in place of C1, if I do C1 minus C2, then 2 minus 2, that will be 0. Then here we'll get minus 2 minus 6. Again 0, minus 2 minus 8. And then we have 2, 8 and 20. And now we can expand this determinant along the first row. So this will give us 2 into and then 16 minus 12. So 16 minus 12, that will be 4. That means determinant of matrix A, this is nothing but 8, right? That is determinant of matrix A. And now we need to find this thing. We have to find determinant of adjoint of 3A, right? Now we know that this thing will be nothing but determinant of 3A, and this raised to n minus 1, n is 3, so n minus 1 will be 2. And we have adjoint twice here, right? Adjoint of 3A. So that means another 2 in exponent, right? Determinant of 3A raised to n minus 1 raised to k. N is the order of matrix, and k is the number of times we have adjoint. So because we have adjoint 2 times, this raised to 2. So this becomes 3 into, and then this we can, if we want to take this 3 outside, remember we have to take 3 cube outside. So 3 cube into determinant of A, and this raised to 4. Now 3 raised to 3 cube raised to 4, so that will be 3 raised to 12. And determinant of A, this was nothing but 8. 8 is 2 cube, this raised to 4. So ultimately this will become 3 raised to 12 into 2 raised to 12. that is determinant of adjoint of 3a. So clearly you can see that m is, if I compare with this one, then 3 raised to 12, 2 raised to 12. We needed m plus n, so clearly m is 12, n is also 12. So that means m plus n, this must be 24. So the correct answer for this problem will be option C. Right? This was not a difficult problem, but there was one important concept that if you apply this logic, that because determinant of adjoint of 3a, this is independent of P and Q. So determinant of this matrix A, that must also be independent of P and Q, and therefore in place of P and Q we can take 0, and then in few lines we can get determinant of matrix A, and then after that we can use properties of adjoint. Adjoint of 3a, determinant of adjoint of 3a. So this will be determinant of 3a raised to n minus 1, and this raised to k. N is the order of matrix and k is the number of times we have adjoint. So from there finally we got 3 raised to 12, 2 raised to 12, m plus n will be 24, and therefore the correct answer for this problem is option C.